continuation to the series on database management systems, let us today have a discussion on database system architecture. The objectives of this unit of discussion are to describe 4 components of a database system, to explain the architecture of DBMS. Let us first discuss what is database. Database is an organized, integrated and shared collection of related data. By organized, we mean that the data is well organized in some specified formats like tables. By integrated, we mean that data is well integrated, well unified with some relationships. And by shared, we mean that the data is shareable amongst many users. Let us now discuss some components of a database system. If we go by the ANSI Spark model, there are 4 components of a database system. The first is data, the second is users, the third is hardware, and the fourth is software. Let us now take up each of these components of the database system in detail. What is data? Data is raw fact, but the data in a database system should have some characteristics. The first characteristic is it should be integrated. By integrated, we mean that it should be unified data without any redundancy. And by shared, we mean that many users can share access the data at the same time. The second component of a database system is users. Users make a very important component of a database system. We have 3 kinds of users of a database system. The first is end users, the second database administrators, and third is application developers. Let us now take up the discussion of each of these users in detail. End users. They are the people who operate the database systems using application programs. They use the database systems for their day-to-day activities, either through some data entry screens or through some query languages. They may be the people in clerical level or may be the people in managerial level. But one thing is sure, that they do not know about the internal working of the database systems. The second category of users is database administrators. Database administrator is one who coordinates the activities of all the users of the database system. He is also responsible for controlling the access to the database by giving the rights to different users as per their requirements. He is also responsible for maintaining data dictionary, which is nothing but a collection of the definition of data items of a database. Thus, we can say that database administrator is one who is the supervisor of the database. The third category of users is application developers. They are those who build the entire system using some languages, such as query languages or some standard programming languages, some form designers, menus, report writers, etc. They also use the data structures which are provided either by the DBA or by the form designer. The third component of a database system is hardware. A database system can be made to run on any conventional computer such as mainframes, PCs and mini computers. It can also be made to run on dedicated database servers. The fourth component is software. Now, this software used in a database system can be categorized into two. The first is DBMS, which stands for Database Management System, and the second is application software. Now let us have a look on what is the difference between database management system software and the application software. The database management system software, it controls the entire database, whereas the application software, it uses the DBMS for data handling, which means it uses the DBMS for data storage, retrieval, insertion, deletion, etc. As a whole, we can say that DBMS is responsible for the access of the data in the database. Let us have a look on what are the functions of DBMS. DBMS, it acts as a layer between the user and the data. It is used to create, manage and access the database. This software should also ensure that there are no data inconsistencies in the database. It should also ensure that the data is defined according to certain standards. And last but not least is that it should provide some online help facility for the end users as well as for some other kind of users who might be looking into what facilities are provided by this particular database system. Let us now move on to our second objective of discussion, that is to understand the DBMS architecture. Now, as we have referred to the DBMS architecture, let us have a look on the figure showing the three levels in this architecture. As we can see in this figure, there are three levels. The external level is represented by many rectangles, whereas the conceptual level and internal level is represented by only single rectangles. Now let us define each of these levels in detail. External level. External level, which is also known as the individual user level. At this level, the DBMS provides each user with a single or shared view of the database. This view may provide the user with the totality of the database or a part of the database. Conceptual level. Conceptual level represents the entire information content of the database, which implies that it is a logical schema representing the totality of the database. Internal level. Internal level, it is a low level representation of the entire database, which means it is concerned with how the data is physically stored in the database, and it is specific to the operating system environment. Now at each level, there is a view associated with it. That is, at external level we have external view, at internal level we have internal view, and at conceptual level we have conceptual view. Let us see what do we understand by external view. In external view, the content of the database as seen by some particular user are defined, which means that whatever the user is seeing in the database is the external view. Let us look at to this using the example shown in this figure. The external view of the student database is shown. The user 1 only likes to see the student name and the student address, and therefore the logical record corresponding to his view contains only student name and student address, whereas the user 2 is concerned with looking into more details, that is student name, student roll number, student address, department and his course details. Therefore, the logical record of user 2 will be as shown here. Thus, we can see that each user has his or her own view of the database. And thus, we can say that each user will have his own external view of the database. That is why the external view is also known as user's individual view. The second type of view is conceptual view. Now referring to the figure which shows the conceptual view of the student database, we see that the student name is defined to be string, the student address is defined to be a string, student roll number is an integer, and the department is a string, as well as the course details is a string. Now let us assume that instead of having the student database, we had a database containing the information about employees, departments, their deductions, salaries, etc. Then the conceptual view would have contained a conceptual record corresponding to each of them as shown in this diagram. Thus we can say that conceptual view consists of many types of conceptual records, and it is defined by means of a conceptual schema. Let us now move on to what is the internal view. The internal view is defined by the internal schema, which not only describes the various stored record types but also specifies the indexes, physical sequence of stored records, etc. Let us move on to the figure that we were referring to see what will be the internal view of the same database. Now the internal view of this database will be that name is a string of length 25, address is a string of length 50, roll number is a string of length 9, then department is a string of length 30, and course is a string of length 30. Thus we can say that internal view is more and more concerned with the physical storage of the data in the database. As shown in this diagram, there are two mappings between these three levels. The first mapping is between the external view and the conceptual view, and the second mapping is between the conceptual view and the internal view. Let us first have a look on what is the mapping between external view and conceptual view. This mapping is used to derive the external record from the conceptual record. Let's say, for example, we define conceptually the student address as two fields, that is the house number and the city to which he belongs. Whereas externally the user would like to see this combined together as an address field. Then the mapping between the conceptual view and the external view should determine that the house number and city should be transformed into address when they are looked at by the user, and when the database is looked at conceptually, then the same thing, that is the address, should be transformed back into the house number and the city. Similarly, the second mapping, that is the mapping between the conceptual view and the internal view, should also ensure some kind of transformation between the two views. That is why we say that it is used to derive conceptual record from the internal record. That is, let us assume that we represent some field as a binary number in the internal view, whereas we represent the same field as a decimal in the conceptual view. Then this mapping should provide some transformation mechanism so that the two types can be converted the either way round. Thus, in this unit of discussion, we have discussed what will be a database system, what will be its four components, that is data, users, and software and hardware. And finally, that we have discussed is the DBMS architecture, which contains three levels according to the ANSI Spark model. That is all for today. Thank you.